All right, team, let's talk about resilience. We all know that when a system goes down, every single second counts. But what if we started architecting our systems to expect failure, not just survive it? That's what we're digging into today, the whole strategic world of failover architecture. Okay, and just a quick heads up before we dive in. We use some AI assistants to help pull this briefing together, basically to synthesize our sources and get to the point faster. So think of it as a sharp tool we used, definitely not generative slop. All right, with that out of the way, let's talk resilience. So here's the game plan. First, we'll hit the core trilemma. It's the trade-off behind everything. Then we'll get into defining our objectives, walk through the temperature spectrum of failover, check out some architectures in practice, and wrap up with a framework for making the right call. Okay, first up, the core resilience trilemma. This is really about understanding the fundamental trade-off we're always making. So everything, and I mean everything we're going to talk about today boils down to this one simple, brutal trade-off. It's called the resilience trilemma, and it's basically this. You get to pick two. You can have fast recovery, or you can have low cost and complexity. But you almost never, ever get all three. You want that near instant recovery? Great, but your cost and complexity are going to go through the roof. You want to keep it cheap and simple? Fine, but you better be okay with a slower recovery. This is the core problem we're here to solve. So, if it's all about trade-offs, how do we make the right ones? Well, that starts with defining our objectives. Okay, so how do we even begin to solve that trilemma? We start by turning fuzzy business needs into hard numbers. The first one you absolutely need to know is the recovery time objective, or RTO. And let's be super clear. This is not a technical spec. It's a business question. The real question is, how long can we afford to be down before things get really, really bad? Are we talking seconds, minutes, hours? The answer to that question is going to drive our entire architecture. And the other side of that coin is the recovery point objective, RPO. If RTO is about time, RPO is about data. It's looking backwards and asking, what's the absolute maximum amount of data we can stand to lose? For a payment system, the answer is probably zero, not a single transaction. But for an internal doc server, maybe we can live with losing a day's worth of updates. And again, who decides? The business decides. And this quote just nails it. RTO and RPO are not technical specs. They're quantified business risk policies. We don't just guess these numbers. They come from a deep analysis that literally weighs the cost of downtime versus the cost of building a more resilient system. So really, what we're doing isn't just engineering. It's financial risk management. All right, so once we have those RTO and RPO numbers, we can start looking at actual solutions. And a really useful way to think about this is what I call the failover temperature spectrum. So let's start at the hottest end of the spectrum, hot failover. Think of this as the always-on, money-is-no-object paradigm. You've got a fully duplicated, fully operational environment running in parallel. Data is getting replicated in real time synchronously. If the primary site hiccups, failover is automatic and happens in seconds, maybe minutes. This is for those systems where even a moment of downtime is a catastrophe. But, you guessed it, it carries the absolute highest price tag in both cost and complexity. Okay, moving down a notch, we have warm failover. This is often the sweet spot, the balanced approach. Here, you've got a partially prepared environment, maybe scaled down a bit to save money. Data isn't replicated in real time, but periodically, asynchronously. Failover is an instant, it's semi-automated and might take a few hours. But honestly, it strikes a really pragmatic balance between cost and speed, which makes it perfect for a lot of our business-critical applications. And finally, at the completely opposite end, we have cold failover. This is your basic safety net. We're talking about maybe just having a facility with power and cooling and a plan to manually restore everything from offline backups. It is by far the cheapest option, but the trade-off is huge. Recovery is a completely manual, very long process. We could be talking days, even weeks, and the potential for data loss is at its highest. Okay, this table right here, this is the whole story on one slide. It just lays out the trade-offs so clearly. Just look at the RTO row. For hot, we're under 15 minutes. For cold, we're at 24 hours plus. Same story for RPO. Near zero data loss for hot versus potentially a full day's worth for cold. And you can see how everything else lines up perfectly. The failover process goes from fully automated to fully manual. The cost goes from high to low. It really drives home that you're picking a complete package here. You can't mix and match. you're not going to get hot site recovery times for cold site prices. It just doesn't work that way. Okay, so we've got the theory down. Let's talk about what these architectures actually look like in practice. So when we go to build these things, it usually boils down to two main patterns. On one hand, you've got active-passive. This is the classic setup. One primary system is handling all the traffic, and a standby is just sitting there, idle, waiting for a failure. It's way simpler to manage. The downside? You're paying for hardware that's doing nothing most of the time. Then you've got active-active. Here, both sites are live and handling traffic. It's much more efficient, no wasted resources. But, and this is a big but, it is way more complex, especially when you start thinking about data consistency. And really, at the heart of all of this is how we handle database replication. It's the key to keeping our standby sites useful. With synchronous replication, we guarantee zero data loss. That's an RPO of 0, because a transaction isn't considered done until it's written to both the primary and the standby. This is absolutely essential for a hot failover setup, but it comes at a price: latency on every single write. On the flip side, you have asynchronous replication. It's way higher performance because the primary just sends the data over and doesn't wait for confirmation. But that creates what's called replication lag, which means there's always a small window for potential data loss. And that makes it a perfect fit for a warm failover strategy. Okay, so we've got the concepts, we've got the patterns. The big question is, how do we, as a team, actually apply all of this? How do we make the right calls for the services we own? What we need is a simple, repeatable framework. And it's just 3 steps. Step 1, business impact analysis. We have to quantify the cost of downtime to figure out the real RTO and RPO for every single app. Step 2, tier your applications. This is huge. We applied a hybrid strategy because, let's be honest, not every system needs the same gold-plated protection. And step 3, and this one is absolutely non-negotiable, we have to continuously test and validate. A plan that you haven't tested isn't a plan, it's just a hypothesis. This idea of a tiered hybrid strategy is how we win. It's how we stay resilient without breaking the bank. So for our tier 1, mission-critical stuff, think customer transactions, core payment platforms, those get the full hot failover treatment, no question. For tier 2, our internal but still business-critical systems like our ERP or CRM, warm failover is perfect for that. And for tier 3, dev/test environments, internal tools, archives, a cold failover is totally fine. It's all about aligning the investment with the actual business risk. And this is what that portfolio might look like in reality. You see that? Maybe only 10% of our entire application portfolio is truly tier 1 mission critical. The vast majority, maybe 60%, is tier 3. What this visual shows us is that we don't have to boil the ocean. We can be surgical. It lets us focus our money, time, and energy on protecting the crown jewels, instead of trying to give everything the same level of Fort Knox security. I'm going to say this again because if you remember one thing from today, it should be this. An untested disaster recovery plan is a plan that is guaranteed to fail. The silent killer here is something called configuration drift. It's those tiny, innocent changes that happen in production every day that slowly but surely break your recovery process. The only way to fight this is to stop treating resilience as a project you do once. It has to be baked right into our CI/CD pipelines. It needs to be validated constantly, automatically. So let's bring it all home. At the end of the day, it all comes back to that Trillemma. Our job as engineers, as a team, is to understand that fundamental trade-off between speed, cost, and complexity. And then we have to make a deliberate, strategic, and defensible choice for every single system we build. Which brings me to my final question, and this is for all of you. Let's make this practical. For that next big project on our roadmap, where on this spectrum do you think we should land? And more importantly, why? Let's open it up for discussion.